finish up this lesson. Okay, so let's say I want us to graph the inverse of y equals x squared plus 4. First thing I'm going to ask you is what would this graph look like? What is it, Layla? Good, it's a parabola. Has this parabola been shifted at all? Yeah, it's been shifted 4 units up. So just to get a visual, I'm going to do a quick sketch. And it looks something like that. So now that will help me find my domain and range. I'm actually going to call this f of x. So I'm going to have the domain of f of x will be the infinities, and the range of f of x will be bracket 4 to infinity. Right. Because I have the domain and range of the original, am I now able to find the domain and range of the inverse? Absolutely. So we're going to say the domain of the inverse is the range of the original, and the range of the inverse is the domain of the original. So now what I want to do is I want to find the equation of the inverse. So I have y equals x squared plus 4. I'm going to swap positions for x and y. So x is equal to y squared plus 4. Now we're going to solve for y. So I'm subtracting that 4. X minus 4 equals y squared. Because I'm solving for y and it's squared, to undo a square, what must I take? The square root. But when we're solving and taking the square root, don't I have to account for the positive and negative value of it? So y will equal plus minus the root of x minus 4. So my inverse equation will be plus minus the root of x minus 4. My domain for this is going to be 4 to infinity, and my range will be the infinities. Right, are we ready to sketch this? All right, forget about the plus minus right now. Let's just look at one at a time. Let's just look at positive. The positive root of x minus 4. What is that, the positive root of x minus 4? What does that look like? Is it a parabola? Is it a V? Is it a shooting star? Is it a line? What is it? Tori? Well, you're right, but just the plus. Just the plus is just a shooting star. So just a plus is a shooting star. So we're 1, 2, 3, 4. We're a shooting star 4 units to the right. And then which way is it shooting and how do you know? So we've shifted 4 units to the right because of the x minus 4. But now am I shooting to the right or am I shooting to the left, and how do you know? Michael? Good. How did you know? The x is positive. And what do you mean the x is positive? Oh, I see what you're saying. That's a good way of looking at it. Good. How else do you know? Good, because the domain is starting at 4 and going to positive infinity. So that means we're going to the right. But this wasn't the only part of my equation, right? The equation of our inverse was the positive root of x minus 4, but also the negative root of x minus 4. So if my a is negative, am I shooting up or am I shooting down? If my a is negative, you shoot down. Good. So I'm again going to 4 and then shooting down. What does this look like? Philip?
It's not a function.
I'm sorry?
It's not a function.
It's not a function?
Yeah.
Correct. Good. But what does this look like?
I don't know.
A parabola. But a parabola that's been what? Rotated. It looks like a rotated parabola. Well, does this make sense? Because I originally started with a parabola. Should its inverse also be a parabola? Good. And now actually Philip answered the next question I was going to ask. Is this a function? No. How do you know it's not a function? Okay.
Vertical line.
It fails the vertical line test, so it's not a function. Was the original a function? Yeah, so is that okay that the original was a function but its inverse was not? That's absolutely fine. All right, let's do another one. That's it. I asked you to graph the inverse. Find and graph the inverse. We did it. So what have I done here? What have I done? Nobody knows what I've done? I switched y and x. So what does this mean? This is the inverse. I want us, before we do anything, go back to the original. So we're going to have y equals the absolute value of x plus 1. Let's get a sketch going. What does this graph look like? Philip?
I don't normally supposed to when we're solving for the inverse, but...
So I'm asking you to graph whatever this thing is, but we don't know what this looks like. But we do know if we switch x and y, we do know what this looks like. So this will help us be able to create this. That's why. Okay, so you tell me, what does this look like? Y equals the absolute value of x plus 1. Sienna? Good, this is a v. Has this v been shifted at all? Yes, shifted where? 1 unit? Up. You got it. So it looks something like that. So let's find our domain and range. So what's the domain here? Good, negative infinity to positive infinity. What's the range?
Square bracket 1 to infinity.
Good, square bracket 1 to infinity. So now let's talk about the inverse. That's the one we need to graph. So for the inverse, the domain is the range of the original. So we're going to say 1 to infinity. And the range is the domain of the original, which is going to be negative infinity to positive infinity. Now, do you all agree when we went back to the original, the only point we actually found was the point 0, 1? That was the only coordinate we actually found. We just sort of sketched the rest, right? Well, when you have the original and then you make the inverse of it, what do you do with your coordinates? You switch x and y. So that 0, 1 becomes 1, 0. And do we agree that the inverse of a v will be a v? Right? Just like the inverse of a shooting star has to be a shooting star. The inverse of a parabola has to still look like a parabola, but it's rotated. So the inverse of a v still needs to look like a v. So now I'm going to use my domain. My domain is starting at 1 and it's going to infinity. So do we agree it's going this way, the v, since it's going to infinity? And then my range is all reals. So that means it's going up forever and down forever. So how does this look? It looks like that.
How do you know it's not a parabola?
Because of the absolute value lines means it's a v. A parabola is x squared. It's not assumed. We learned that. Remember all the parent functions I said you guys had to memorize?
Yeah, no. I'm just saying, no matter what, any absolute value is always going to have a v as its, point back.
No, because remember when we did, the absolute value of x squared plus 1, that was a parabola, but then we took the absolute value of it. But if it's an absolute value with the x of degree of 1, it will be a v.
You have to change the inverse equation to a y equals.
Nope, because they gave it to us, we didn't come up with it. So they gave us that, so we don't need to manipulate it at all.
So when you're doing these problems, you wouldn't have to find the x and y intercept.
Nope, if I just say, well, you found the x-intercept. If there was going to be a y-intercept, I would ask you to find it, and I'll tell you the problems I want you to find those.
Right.
But right here, there was only an x-intercept, and we found it. All right, I want you guys to try this one on your own. So I'm not asking you to sketch in this one. This one I am not asking for a sketch. I want you just to find the domain and range of x equals the absolute value of y minus 6. So I'm not asking you to sketch it. I'm just asking you to find the domain and range. Very similar to what we just did.
Go back to the original.
It's literally the same. Just
This is
just same thing as just did.
it's going to be y equals x minus 2.
Domain is correct.
Yes. Oh wait, shoot, it's inside. Oh my god, everything. You're serious right now.
I want to graph it. I want to graph it.
Oh, this is a shooting star. I mean, this is a ship.
Minus x.
Oh, it just goes to cancel.
Who wants to come teach us this one?
I think Rob.
No, I didn't get it, bro.
No, I didn't get it.
Why didn't you get it?
I wrote it down wrong.
Oh, you wrote it down wrong? Philip already went up. Somebody else. I'll do eeny, meeny, miny, mo.
Okay.
Eeny, meeny, miny, mo.
Yes.
All right. Eeny, meeny, miny, mo. Catch a tiger by his toe. If he hollers, let him go. My mother says to pick the very best one, and you are it. Sienna, you win!
I don't understand how to do this.
Oh, we'll help you. Oh.
You're so mean.
No, I'm not.
Yeah, James.
I'm
What
sorry,
are
man.
you doing, James? What are you doing? I'm just happy.
All right, guys, we are helping Sienna because we are a team here. So you guys tell her what's the first thing she should do.
Replace the X and Y.
Go back to the original by switching X and Y. Correct.
Oh, I got it.
I don't know what to do. This is already up
Switch
I
X
really
and
don't know
Y.
what to do.
You're so.
All right. Then from here, what do we do?
Shoot. It's like,
So yeah. Good. Find the domain and range of the original. So what does this look like? What does this graph look like? Corey? A V. Yeah. So it's a V that's been shifted where? Y'all are killing me. This is like the 10th day we've done this, and it's like crickets. Okay, we're moving 6 units where? To the right. So we're V moving 6 units to the right. Good.
It's the
So
document.
this is just giving us an idea. I wasn't asking you to graph it, so this is just helping us with the domain and range. So now that we have that generalized sketch, would we be able to figure out the domain and range? We should.
Why is it 6? X, Y, 6. What?
So Sienna, you tell me that domain is what to what? We're looking left, furthest right.
Is it negative infinity to positive?
You got it. Negative infinity to positive infinity.
And then the range is highest to lowest?
Lowest to highest.
Lowest to highest. So is it y is greater than or equal to 6?
Well, look
0?
at 0. You got it. You got it. Okay, so now that's the domain and range of the original. Now we want to go back to the inverse. So what do we do to find the domain and range of the inverse?
Just switch it.
Just switch them. You got it.
Okay. So
I did it wrong. Open it. Dude. You couldn't have done that. What is that?
So domain is always X and range is always Y.
oh yeah.
So we'll do X is greater than or equal to 0. You got it. Okay, good. See? Was that so bad? Yeah? You guys are so dramatic. Okay. Guys, just some advice. When we're doing interval notation, write your variables such that and put your brackets.
How would we graph something?
What do you mean? We just graphed something like this
Yeah.
before.
Oh.
So it would look like this. We did, guys, we pretty much did the same exact problem 2 minutes ago, but instead I just shifted it in a different direction. Y'all are killing me. What's wrong, Max? What's wrong?
No, I got it.
You got it? Okay. So,
Because it switches X and Y.
so right now, do we agree that our original was a function? Was our inverse a function?
No.
No. So now how will we know? How will we know by the original if the inverse is going to be a function? Well, let's write it down. When will a function have an inverse that is also a function? Layla?
If it's linear?
Linears will always have an inverse that's a function, but that's not the only one. I haven't told you guys this, but you're taking guesses, Max? The inverse. Okay, yeah. The disco dancer. Okay, guys. So there's a very generalized way to find it. If the original passes the horizontal line test, that means the function is 1-to-1 every x value, or doesn't matter, every y value has exactly one x value. Then it will be a function. Then its inverse will be a function. Sorry, then its inverse will be a function. Okay, let me give you an example. Is the inverse of y equals x squared a function? Well, y equals x squared, isn't that a parabola? Isn't that a parent function with a turning point at 0, 0? So it looks something like that. So I want to know if its inverse is going to be a function. We're going to perform the horizontal line test. And what happens when we perform the horizontal line test? We end up touching in more than one spot. So it fails the horizontal line test. So therefore, inverse is not a function. Okay, and the other way we look at it is every y has exactly one x. If you look, let's say the points over here, if you look at the x versus the y, well, I have, let's say this is -1, +1, 1. So this is, here are my x coordinates, here's my y coordinates. So I have -1, and that goes to +1. But then I have +1, and that also goes to +1. So what's happening? That y belongs to two different x's. It's not 1-to-1. For it to be 1-to-1, every x and every y, they need exactly one x or one y corresponding. There's no two of anything. Nobody's sharing. It's 1-to-1. So this also fails. Horizontal line test. All right, next one. F of x equals x plus 2. Is its inverse a function? Well, do we agree x plus 2 is a line? So I'm going to quick sketch it. My y-intercept is 2, and my slope is 1 over 1. So it looks something like this. And then I'm going to perform the horizontal line test. And will it pass the horizontal line test? Yes. So its inverse is a function. All right, the very last thing we're doing today. Okay, there is a way to determine if two functions are inverses. And on the test, I will only accept this proof of it. Meaning sometimes people take the equation and manipulate it and show that they're the same. Like, oh, look, I found the inverse of this one and that's the same. We're not going to do that. You're not allowed to do that. On the test, the only method I will accept is this proof I'm showing you. So, two functions are inverses if and only if f of g of x is equal to x and g of f of x is equal to x. This will be the only proof I will accept. Okay, so let me give you an example. Our our f of x equals 1 over x plus 1, and g of x equals 1 minus x over x inverses. So there are two things I need to show. I need to show that f of g of x is equal to x, and I need to show that g of f of x is equal to x. If we're able to successfully show both of those, then they're inverses. Let's say one is x and the other one is not x. Will they be inverses? No. All right, so for the first one, I have to show f of g of x is equal to x. So I'm finding f of, now g of x is x minus 1 minus x over x. So now I'm finding f of 1 minus x over x. Which, what does this mean? This f of 1 minus x over x means I'm going to f of x. Wherever I see x, I'm now going to substitute in 1 minus x over x. That's what this is telling us to do. So I'm going to have 1 over, now instead of x, I'm putting in this whole thing. 1 minus x over x plus 1. Everybody okay with what I've done so far? I'm going to work in that denominator. I'm going to try to simplify it down. So in that denominator, I'm going to make a common denominator. So it's going to be 1 over 1 minus x over x plus x over x. So now I'm going to have 1 over 1 minus x plus x over x. What happens with those x's in the numerator? Well, not the numerator, the bottom numerator, the negative x and positive x. Don't they cancel? So now I'm going to have 1 over 1 over x. At this point, this is going to be 1 divided by, fraction bar means division, 1 over x. Keep, change, flip. Keep, change division to multiplication, flip 1 over x to x over 1, or just x. And what's 1 times x? X. So did we show f of g of x is equal to x? Yes. Am I done? No. Now I have to show the other side of things. I have to show that g of 1 over x plus 1 is equal to x. So I'm going to g of x. Anytime I see x, I'm now subbing in, instead of x, 1 over x plus 1. So what does this look like? It's going to look like 1 minus 1 over x plus 1 over 1 over x plus 1. Anybody confused with how I did this? How I got those? James, you good? Which part?
1 minus 1 over x plus 1.
So when we did g of 1 over x plus 1, we're now going to g of x. Wherever you see an x here, you're now subbing in 1 over x plus 1. So here it was 1 minus x, so instead of that x, I have 1 over x plus 1. And then there was another x in the denominator, so again, that gets 1 over x plus 1. All right, I'm going to work in the numerator now. I'm going to make a common denominator, and my common denominator in that top numerator is going to be x plus 1. So this is going to be x plus 1 over x plus 1 minus 1 over x plus 1 all over 1 over x plus 1. In the top of this, now that I have a common denominator, I can combine the numerators. What's a positive 1 and a negative 1? What happens there? They cancel right out. So now we're left with x over x plus 1 over 1 over x plus 1. So I'm going to write this as x over x plus 1 division sign 1 over x plus 1. Keep, change, flip. The x plus 1's cancel, and I'm left with just x. Are they inverses? Yes. Because f of g of x equals x, and g of f of x is equal to x. All right, guys, we are done for today. I've already